chain rules. This is day 6, 7. I don't know what day we're on. Day 6. And today is August 28th. And yes, we have next Monday off, so that is nice. Thank you, sir. So again, if we want to find the derivative of this guy, kind of the only way we know now is to multiply it all out to turn it into a polynomial. And then, Monty, what's the derivative of that first term? 126x. Amy, the derivative of 42x? 42. And Lauren, the derivative of 7? 0. Yes. We got the easy one, but sometimes people forget and they just copy down the plus 7. It's like, thought you knew better. So that was kind of a pain, but not terrible. On the other hand, what if we had 3x plus 1 to the 9th? I mean, nobody really wants to do this, right? Like, you're thinking, Mr. Wolf's not really going to do this, is he? Surely not. No, it would take forever. I mean, you have the skills to do it. It would just take forever. Time-consuming, tedious to multiply it all out. Well, there is a shortcut to do that sort of nested function thing. Some function involved in another function. And that's what the chain rule is. I think it's easier in practice than this makes it out to be. But the derivative of f of g of x is f prime of g times g prime. I'm going to rewrite it without the x's. F prime of g times g prime. I wouldn't really worry about this other one just yet. It's chained because we chain it together. Like we've chained the f and the g and chained by multiplication. Here's a picture of this guy using or eating a Tootsie Roll Pop. How to eat a Tootsie Roll Pop. It's like, oh, I didn't realize we were going to talk about that in calculus today. Well, again, I was supposed to bring these for you. I'll bring them tomorrow. One layer at a time on a Tootsie Roll Pop. To make a point, I did this a couple years ago, and to be silly, some kid in the back, he had taken the wrapper off. He put the whole thing in his mouth, the wrapper and all, and bit into it. And like, that's terrible for your teeth. I think it's disgusting for the paper, but he did it. And that was he was trying to get attention to himself, be a class clown, all that stuff. But it illustrates the point. That's not how you eat a Tootsie Roll Pop. One layer at a time. By the way, all these rules are going to apply to the chain rule. So, one layer at a time. In fact, that's about it. One layer at a time. I think that's it. I thought that I had more rules to that, but I know what it is. One layer at a time, and the second rule is, this is kind of dumb, but you have to work from the outside in, right? You said wrapper first. You cannot, you just cannot eat the Tootsie Roll first. Like, you have to work your way there. You got to take off the wrapper, then you got to do the candy, or the hard candy, and then you get to the Tootsie Roll. So, wrapper, hard candy, Tootsie Roll. I know, and you're like thinking, why are we talking about Tootsie Rolls here? Because it's exactly the same for the chain rule. You handle one derivative at a time, and you work from the outermost function in, which is a little bit backwards. Usually in math, we start at the inside, like when we plug something in. You plug in on the innermost part of the parentheses stuff, and then kind of work your way out. This is the opposite. You work from outside in. Here it is. You got to eat the outer part first, leaving the inner part alone, unless you're the kid that wants to break his teeth while he's eating it. Okay, here's the connection. Take the derivative of the outer part of the function, but leave the inside part alone. So when you take that first derivative, like leave the inside stuff alone, and then go to the inside stuff and multiply by its derivative. That's the chain part. You chain it together. Let's do some examples. Maybe this will make more sense here. Let's see. So I've got 2, 3x minus 7, all to the 8th. All right, well, I see basically two functions here. I got 3x minus 7, and then I got something to the 8th. What's the outermost function, the 3x minus 7 or the 8? The 8. So let's handle the 8 first. So how do I handle the 8? Forget about the 3x minus 7. If I had 2 times something to the 8th, what would I do to take that derivative? Move the 8 down and reduce the power by 1. That's handling the outer function. Move the 8 down, reduce the power by 1. That inside stuff stays the same, because while we're working on one derivative, we don't get to mess with other derivatives. We only do one derivative at a time. So that 3x minus 7 stays in there. Now, I still need to take the derivative of 3x minus 7, so I'm going to chain it together, and I've handled everything else. What's the derivative of 3x minus 7? 3. Right? I handled the wrapper, now moving to the inside part, that derivative is 3. Then we could clean that up if we want to, but that's also a safe stop, and I really want to focus on the chain rule part, so I'm going to leave that alone right now. Alright, 3 sine 5x to the 4th. So I've got sine of 5x to the 4th. I think there's two functions going on here. There's sine, and then there's 5x to the 4th. Which one is the outermost? What's the wrapper? The sine. And then what's the derivative of sine? Cosine. So the derivative of sine is cosine. But leave that inner stuff alone, because while we're taking care of the wrapper, we leave the hard candy alone. Then we can get to the hard candy. And what's the derivative of 5x to the 4th? 20x3. Yeah, 20x cubed. I am going to clean up that one, because that looks... Anytime you have a trig function and then something afterwards, it just looks bad, and people end up cosigning the wrong thing. So I'm going to move the 20x cubed up front. So just a little cleanup work on that one. Right, -9 tangent of 4x. I guess I didn't explicitly say it, but a constant out front can just kind of go along for the ride. I'm not worried about that. And I've got tangent and 4x. Which is the wrapper? The tangent. And what's the derivative of tangent? Secant squared. So secant squared. Secant squared of what? Of 4x. Right? You only do one derivative at a time, one layer at a time. So leave the 4x alone. And then the derivative of 4x is 4. So we'll multiply by 4. That's the chaining it together. Now, those three examples only had 2 links in the chain, so it's hardly a chain. But this last one, like a nested chain rule, meaning, well, the other 2 were nested as well, but this has like multiple chain links. Lots of links, chain links. So I've got a secant, a fifth, a 3x to the 8th. What's the outermost function here? Okay, well, that was not really a function, but that's fair. I'll write down the 2. That's the constant out front. Now what do I need to take the derivative of first? This one's tricky. It's not secant. It's because that fifth is in a weird spot. But that fifth means secant of 3x to the 8th all to the 5th. Now I think it becomes a little easier to see what I need to take the derivative of first. So that fifth, I got something to the fifth. So how do I handle, Leo, how do I handle something to the fifth? So again, I don't care about the inside. I got something to the fifth. How do I take the derivative of something to the fifth?
You multiply the inside by 5 and then
So I'll bring the 5 down, and then what happens to the exponent?
it goes down 1. So
It goes down 1 to 4. And then last question, Leo, what goes on the inside here of this parentheses?
this secant.
Yep, secant of 3x to the 8th. One layer at a time. Okay, so I took care of the 5. My next layer down is, Tyler, you tell me, what's my next thing to handle? The secant, and what's the derivative of secant? It's okay, that's one we don't know well. Yes. So secant tangent, what is the argument of the secant and the tangent? What am I taking the secant and tangent of?
3x to the 8th.
Good, 3x to the 8th. Alright, so there's my second chain. And then lastly is 3x to the 8th. Mia, what's the derivative of 3x to the 8th? (24x to the 8 times 3 is 24. I like that. What do you do with this exponent?
7.
Yes. So now we took care of that last piece. So that was a harder one because it had 3 pieces to it. Maybe 4 if you want to argue that that constant was one of the pieces. So there's our wrapper, there's our hard candy, and there's the Tootsie Roll. And they are chained together. So outside in, one layer at a time. The most common mistake when people use the chain roll is that they basically smush it all together. They're like the kid in the back who eats the Tootsie Roll all at one time. Like just squishes it all and takes all the derivatives at once. And that's always going to be one of the wrong answers. I hesitate to even write it. But I guarantee you on a multiple choice test, one wrong answer is going to be, let's see, derivative of secant is, derivative of, so 5, and then the derivative of secant is secant tangent, but the derivative of 3x to the 8th is 24x to the 7th. So something like that, and then maybe all that to the 4th. It's like, well, you did all the rules, but you ate them all at once. That's not how you eat a Tootsie Roll Pop. Right? At least that would break your teeth and you'd be chewing on a wrapper. Like, you got to go one step at a time and chain them together. That's the whole point. There's no chain in there. That's just that's a mouthful of Tootsie Roll Pop plus a wrapper. I don't know if this helps. One way to say it is leave the parentheses alone. If it started in parentheses, it stays in parentheses. So that 3x to the 8th, that's still part of the answer until we get to the end, and then we take its derivative. That's why I'm a little hesitant to focus on that. All right, I think you have one page of example problems, but somehow I didn't get that page. So. Oh, you don't have that page either. Nope. I didn't print that page. Or I didn't copy that page. I have one copy of it. So I've got a gazillion examples. We're not going to do all of them. But we'll do some. Oh, I left it running. Oh well. Some more examples. F of x equals, parentheses, so there's a hint of what's coming. X to the fourth minus 3x squared plus 9x, all cubed. All right, so this is just examples. Is there a back? Are you out of... There's a homework packet. Somewhere you can put these examples down. So Quinn, can you tell, before we even start, like how many links to this chain there are going to be?
1. I don't know.
I don't know if I asked that question very well. What would you do first? Let me just ask it that way. Because if you can get the right answer, it doesn't matter the rest of the questions.
Do like the derivative, like the 1 in front kind of.
Okay.
3 and 1.
So there's a 1 in front, so that didn't really do anything. Now what about this 3?
Make it like 1 times 3 and squared.
Good, that's a good way to say it. 3 and then squared, because that's the rule. Right? The power rule is move the number down front, decrease the power by 1. So we did the derivative. One wrapper at a time, or one step at a time. What goes on the inside here? Like, do I need to take the derivative of this thing, or do I just need to copy that thing down? Just bring it down, right? Because we already did a derivative. We don't want to eat too many things at once here. We just bring it down. Now we'll chain it to the derivative of what's on the inside. So, Nick, what is the derivative of the stuff on the inside?
4x to the third, and then negative 6x, and then just 9.
Good. Two links to that chain. Number 2, find the slope of, so what am I asking you to do when I use the word slope there? Derivative. We just want to remind you of all the different words. G of x equals 3, parentheses, x cubed minus x minus 3, all to the 33. That would be terrible. But as a derivative, it's not really that bad. So you try that one. Make sure that 3x squared minus 1 is in parentheses so that you're multiplying by all of it. If you don't have the parentheses, you'd only be multiplying by 3x squared. So make sure that each chain piece is in parentheses. So this next one has 2 pieces. Just want you to see the difference in y equals basically cosine of x all to the 6th versus cosine of x to the 6th. Alright, so those are not the same thing. Add some parentheses to make sure there. So do both of those, and you should not get the same answer. There's a small hint. Those are not the same problem, so you shouldn't get the same answer. d2y over dx2. We showed it once last week. Well, dy dx is the first derivative. This is a second derivative. And there's no magic to jumping to a second derivative. You just have to find the derivative twice. So there's no like special formula to go to the third or fourth derivative. You just have to walk your way there. So the first derivative, the derivative of tangent. Joe, what's the derivative of tangent?
Secant squared.
Secant squared. So 8 secant squared x. That did not involve the chain rule because our tangent is only one function, so no chaining to anything there. But if I want a second derivative, and these trig functions where they write the squared like that always throws people off. If it's helpful for you, it might be wise to rewrite it like that. Then it becomes a little more clear as to who the outer function is. When it's written like this, you might be tempted to think secant is the outermost function. But when you write it like this, it's pretty clear that the squared is the outermost. So 8 times 2 secant x to the first, right? One derivative at a time. Do not try to eat them all at once. And then the derivative of secant is secant tangent. And that one's kind of interesting because, that's a perfectly good safe stop, but our first link of chain and second link of chain had a little bit of in common stuff, so we would probably write that as secant squared x times tangent of x. All right, one more. We may not get through with it, but it's just to remind you of something. Find the IROC, instantaneous rate of change, of f of x equals the square root of, we'll keep it relatively simple, 2x to the fourth plus 3. How do we find the derivative of square roots? What's another way to write a square root? What power would be the same thing as a square root? 1/2. So I'd rewrite that as a 1/2. I haven't done any calculus yet. I've got to know my algebra well. Now I'm ready to do a chain rule. So 1/2 times all of that to the negative 1/2, and then chained onto 8x cubed. But we got time to do that. So 1/2 out front, decrease the power by 1. And you may notice I'm writing these in what feels like maybe a weird order and even leaving that blank there, because I'm trying to emphasize one derivative at a time. That's the power rule. So that's the derivative we're working on, which means we leave the rest of this stuff alone. Now, we do need to take the derivative of the rest, but that's the next step. That's the chain part. So 8x cubed. And then that would probably be cleaned up. 8 and 2 would reduce. This stuff, negative 1/2 means a square root in the bottom. So it'd probably look like that on a multiple choice test. It's another great example of calculus is easy, algebra is hard. Right? Algebra steps at the beginning, algebra steps at the end. The calculus really wasn't bad, but the algebra at the front and end is what can get us. Alright, chain rule is worksheet 6. Work on that. We'll answer some questions tomorrow. We'll review tomorrow. You have a test on Wednesday. You have homework due on Wednesday. You've got an AP classroom quiz due by Thursday for some bonus points on the test. A lot of stuff going on this week.